Most people think they know what made the 1969 Chevrolet ZL1 special. You've heard it was rare, expensive, and powerful. But what you didn't know is that this engine was never supposed to exist in street cars, cost more than most people's houses, and was so misunderstood that buyers literally returned them to dealerships. In the next few minutes, you'll discover 20 weird facts about the ZL1 427 that will completely change how you see this legendary motor, including one fact about these engines that's so bizarre, it involves a surgical clean room and a connection to a completely different car company decades later. Can-Am Racing Origins. The ZL1 427 wasn't born in Detroit's muscle car planning rooms. It came from the brutal world of Can-Am racing. Bruce McLaren himself pushed Chevrolet to develop this all-aluminum monster for his race cars. The Canadian-American Challenge Cup Series had no engine displacement limits, and McLaren wanted something that could compete with the massive 7-liter engines dominating the sport. Chevrolet's response was an aluminum version of their 427 big block, designed specifically for racing where every pound mattered. The engine was never intended for street use. It was meant to scream around road courses at 8,000 RPM, not idle in traffic. But when word got out about this exotic power plant, performance-hungry dealers started asking questions. The racing connection explains why the ZL1 was so temperamental on the street. It had race-spec valve springs that were so stiff, they'd literally eat through rocker arms if you didn't rev the engine regularly. The cam timing was optimized for high RPM power, making it surge and stumble at low speeds. Even the oiling system was designed for sustained high G cornering, not stop-and-go driving. This wasn't a street engine with racing aspirations. It was a pure race engine that somehow found its way under the hoods of 69 street cars. Only 69 Camaros ZL1s exist. When Chevrolet approved COPO 9560 for the 1969 Camaro, they had no idea they were creating one of the rarest muscle cars in history. Only 69 examples rolled off the assembly line, and the story of why is pure sticker shock. The ZL1 engine package alone cost $4,160, more than a complete base model Camaro with a V8. To put that in perspective, you could buy a brand new Corvette for less than the cost of just this engine option. The astronomical price wasn't arbitrary. Each engine required 16 hours of hand assembly in a special clean room at the Tonawanda engine plant. The aluminum casting process was so expensive and time-consuming that General Motors lost money on every ZL1 they sold, even at that eye-watering price. Fred Gibbs Chevrolet in Illinois ordered 50 of these Camaros, planning to dominate NHRA superstock racing. Dick Harrell, the famous drag racer, helped convince Gibb that these cars would fly off the lot to racers. They were wrong. When customers saw $7,200 window stickers on what looked like regular Camaros, they walked away. Many of Gibbs' cars sat unsold for months, and several were actually returned to Chevrolet and redistributed to other dealers who thought they could move them. The remaining 19 cars were scattered across the country to dealers who special ordered them for specific customers. 2 Corvettes got the ZL1. While Camaro enthusiasts know about their 69 ZL1s, the Corvette story is even more exclusive. Only 2 1969 Corvettes were built with RPO ZL1. The option price was even more shocking in the Corvette, $4,718 on top of the base price. With mandatory options like heavy-duty brakes, special suspension, and transistor ignition, a ZL1 Corvette pushed past $10,000. That was serious money in 1969, enough to buy a nice house in many parts of the country. Both cars were special ordered through high-performance dealers who had customers willing to pay anything for the ultimate Corvette. The first was ordered in Daytona yellow, the second in Can-Am white, both colors chosen to show off these cars' racing heritage. These weren't just expensive Corvettes with big engines. Ordering RPO ZL1 triggered a cascade of mandatory deletions and additions. You couldn't get air conditioning, radio, or power steering. The cars came with the brutal M22 Rock Crusher, 4-speed transmission, J56 heavy-duty brakes, and F41 special suspension. They were essentially race cars with license plates. The two Corvette ZL1s represent the absolute peak of Chevrolet's racing technology made street legal. Today, they're among the most valuable Corvettes ever built, with estimates suggesting they could fetch over $3 million at auction. The $4,000 sticker shock. Imagine walking into a Chevrolet dealership in 1969, excited to buy a new Camaro, and seeing a price tag over $7,000. That's exactly what happened when the ZL1 Camaros hit showroom floors, and customer reactions ranged from disbelief to anger. The base price for a regular Camaro was around $2,500. Even a well-equipped Super Sport with a 396 big block cost less than $4,000. But the ZL1 package added $4,160 to the bottom line, just for the engine. Dealers struggled to explain why this Camaro cost more than a Cadillac. From the outside, it looked like any other Camaro. There were no special badges, no unique body panels, nothing to justify the price to casual observers. Sales managers watched potential buyers literally laugh and walk out when they heard the price. Some customers accused dealers of price gouging. Fred Gibbs Chevrolet, which had ordered 50 cars, found themselves in a nightmare scenario. They had over $350,000 tied up in inventory that wouldn't move. Salesmen tried everything, emphasizing the racing pedigree, explaining the aluminum construction, even offering test drives to serious buyers. Nothing worked. The cars sat so long that Gibb eventually had to return several to Chevrolet. Other dealers who received redistributed ZL1s often didn't even advertise them, instead calling known racers and collectors directly. The price resistance was so strong that some ZL1s were eventually sold at a loss just to move them off the lots. Clean room assembly required. Every ZL1 427 was built in what Chevrolet called a surgically clean room at the Tonawanda engine plant in New York. This wasn't marketing hype. It was an actual clean room environment more suited to building precision instruments than automobile engines. Workers wore special clothing and followed strict protocols to prevent any contamination during assembly. The reason for this extreme cleanliness was the aluminum construction. Unlike iron blocks that could tolerate some debris during assembly, aluminum was much more sensitive to contamination. A single metal shaving in the wrong place could score a cylinder wall or damage a bearing surface. The soft aluminum also required special handling to prevent nicks and scratches that could become stress points under racing conditions. Each engine took approximately 16 hours to hand assemble, compared to less than an hour for a regular production big block. Technicians individually measured and matched components, checking clearances multiple times during assembly. Every bolt was torqued by hand with precision tools, not air wrenches. The process was so labor-intensive that Chevrolet could only build a handful of ZL1s per week. The clean room had its own air filtration system that created positive pressure to keep contaminants out. Tools were cleaned between each use, and parts were kept in sealed containers until needed. This level of care was unprecedented for a production car engine and contributed significantly to the ZL1's astronomical cost. It also explains why so few were built. The clean room could only handle limited production without disrupting Chevrolet's other specialty engine programs. Aluminum big block weighs like a small block. The most revolutionary aspect of the ZL1 wasn't its power, it was its weight. At approximately 520 pounds fully dressed, this 427 cubic inch big block weighed about the same as an iron 327 small block. This was the entire point of the aluminum construction, and it transformed the handle and dynamics of any car it was installed in. The weight savings came from everywhere. The block itself was 100 pounds lighter than its iron L88 counterpart. The aluminum cylinder head saved another 60 pounds. Even the intake manifold was aluminum, trimming more weight from the package. In a front-heavy muscle car, removing 160 pounds from ahead of the front axle made a dramatic difference in weight distribution and handling. Racers immediately recognized the advantage. In Can-Am racing, where the ZL1 was originally intended, the lightweight allowed better braking, improved cornering, and reduced tire wear. In drag racing, the lower weight meant quicker acceleration and better weight transfer. Even in street driving, ZL1-equipped cars felt more nimble and responsive than their iron big block counterparts. The aluminum construction required special engineering solutions. Steel cylinder sleeves were pressed into the aluminum block to provide a durable wear surface. Special gaskets and sealants were needed to handle the different expansion rates of aluminum versus iron. The engine even required a specific coolant mixture to prevent galvanic corrosion. But the payoff was worth it. You got big block power without the usual big block weight penalty. Underrated at 430 horsepower, Chevrolet's official rating of 430 horsepower for the ZL1 was perhaps the biggest lie in muscle car history. This wasn't just conservative, it was deliberately misleading, and everyone involved knew it. Dyno tests consistently showed stock ZL1s producing between 525 and 550 horsepower, with some examples pushing even higher. The underrating served multiple purposes, none of them accidental. For insurance purposes, a lower horsepower rating meant lower premiums for buyers, though with the ZL1's price, insurance was probably the least of their worries. For NHRA racing classification, the lower rating helped the cars compete in more favorable classes. But mostly, it was about flying under the radar of corporate executives who were already nervous about the horsepower wars. Magazine tests of the era revealed the truth. Hot Rod magazine dyno tested a completely stock ZL1 and recorded 545 horsepower at 6,500 RPM. Carcraft found similar numbers. These weren't modified engines. They were exactly as delivered from Chevrolet. The real number was so high that some magazines initially thought their dynos were reading incorrectly. The massive power came from racing spec components throughout. 12-to-1 compression ratio meant this engine demanded high-octane fuel. The radical solid lifter camshaft with 0.560-inch intake and 0.600-inch exhaust lift was designed for high RPM operation. The huge 850 CFM Holley 4-barrel could flow enough air to support well over 600 horsepower. Every component was sized for racing, not street driving, which explains why the factory rating was such a joke. Winters Foundry Snowflake Castings. The aluminum castings for ZL1 blocks and heads came from Winters Foundry in Ohio, and they carried distinctive snowflake identification marks that have become legendary among collectors. These weren't random markings. They were Winters' way of identifying their premium aluminum castings, and they've become one of the key ways to authenticate original ZL1 components today. Winters Foundry had been chosen because of their experience with high-strength aluminum castings for the aerospace industry. The ZL1 blocks required a special aluminum alloy and casting process that most automotive foundries couldn't handle. The molten aluminum had to be poured at exactly the right temperature and cooled at a specific rate to achieve the necessary strength and dimensional stability. Only about 300 ZL1 blocks were cast during the entire production run. This number included replacement blocks and over-the-counter sales, not just the ones installed in cars. Each block was individually inspected and sonic tested to ensure proper wall thickness throughout. Any block that didn't meet specifications was scrapped and remelted. The snowflake castings have become so valuable that forgeries exist. Original Winters blocks have specific characteristics beyond just the snowflake mark. the casting quality, the date codes, even the texture of the aluminum in certain areas. Experts can spot fakes, but it requires detailed knowledge of original production techniques. Today, an original winter snowflake ZL1 block alone can sell for more than most complete cars, testament to their rarity and desirability among collectors and racers. Head design changed mid-production. One of the oddest quirks of ZL1 production was a significant change in cylinder head design that happened in March 1969, right in the middle of the limited production run. Early ZL1s used closed chamber heads with smaller combustion chambers, while later engines received open chamber designs. This wasn't a running change for improvement, it was about parts availability and production efficiency. The closed chamber heads were technically superior for performance, offering better quench characteristics and more efficient combustion, but they required special pistons to achieve the proper compression ratio with the ZL1's tall deck height. When Chevrolet ran low on these special pistons, they switched to open chamber heads that could use the same pistons as the L88 iron big block. This change created two distinct versions of the ZL1, though Chevrolet never officially acknowledged the difference. Early closed-chamber cars had slightly different power characteristics, with better low-end torque and crisper throttle response. The open-chamber versions breathed better at high RPM, but gave up some bottom-end power. For collectors today, determining which heads a car has requires checking casting numbers and date codes. The change happened around engine sequence number 50, but there was overlap as Tonawanda used up existing inventory. Some cars even left the factory with one style of head and had the other installed as warranty replacements. This mid-production change adds another layer of complexity to authenticating and restoring ZL1 engines. It also means that no two ZL1s are exactly alike in performance characteristics. Corvette ZL1s required racing options. Ordering RPO ZL1 in a Corvette triggered a mandatory selection of options that transformed the car into barely street-legal race equipment. You couldn't just check the ZL1 box and call it a day. Chevrolet forced buyers to accept a specific configuration whether they wanted it or not. This wasn't about upselling, it was about liability and capability. First, you had to take the M22 close ratio 4-speed transmission, nicknamed the Rock Crusher, for its straight-cut gears that howled like a NASCAR gearbox. No automatics allowed. Turbo Hydromatic couldn't handle the ZL1's torque. You also got J56 heavy-duty brakes with sintered metallic linings that squealed like a freight train but could haul the car down from speed repeatedly without fade. The K66 transistor ignition was mandatory because conventional points couldn't handle the high RPM operation. F41 special suspension stiffened everything to race car levels, making the ride harsh enough to loosen dental fillings. Power steering was deleted. Chevrolet figured if you were man enough to handle a ZL1, you could wrestle the steering wheel yourself. But the most telling required deletion was air conditioning and radio. Chevrolet literally wouldn't let you order comfort options in a ZL1 Corvette. The message was clear. This was a race car that happened to be street legal, not a grand tourer with a big engine. Even the battery was relocated to behind the seats for better weight distribution. These weren't options you could decline. Order a ZL1 and you got the whole package. Period. Drag racing conception story. The ZL1 Camaro existed because of one man's vision for drag racing domination. Dick Harrell, the famous Texas drag racer known as Mr. Chevrolet, saw an opportunity when he learned about the aluminum 427. He approached Fred Gibb, a performance-oriented Chevrolet dealer in Illinois, with a simple proposition: order 50 ZL1 Camaros through the central office production order system, and they'd own superstock drag racing. Harrell knew the NHRA rulebook inside and out. He calculated that the ZL1's combination of big block power and small block weight would create an unbeatable combination in heads-up racing. The aluminum engine would allow the Camaro to run in a lighter class while making more power than the competition. On paper, it was brilliant. The reality proved more complicated. Copo 9560 was approved, but the cars that arrived were so expensive that racers balked. The street price of over $7,000 was hard to swallow when you could build a competitive race car for half that amount. Many of the intended racing customers walked away, leaving Gibb with dozens of unsold ZL1s. Still, the cars that did make it to drag strips proved Harold's theory correct. ZL1 Camaros immediately began setting records and winning races. They were particularly dominant in super stock classes, where the favorable weight break gave them a significant advantage. Professional racers like Don Yenko and Baldwin Motion quickly recognized the ZL1's potential and snatched up examples for their own racing programs. The irony is that while the ZL1 Camaro was a commercial failure, it succeeded brilliantly at its intended purpose: drag racing domination. Wrong carburetor factory mistake. In one of the most embarrassing production errors in muscle car history, many of the first ZL1 Camaros delivered to Fred Gibb Chevrolet arrived with the wrong carburetors. Instead of the correct Holley part number 3955205 specifically calibrated for the ZL1, workers had installed standard L88 carburetors. This might seem like a minor mix-up, but it caused major problems. The ZL1's higher compression ratio and different cam timing required specific jetting and metering block calibration. The wrong carburetor made these already temperamental engines run even worse, if they ran at all. Some cars wouldn't start, others ran so rich they fouled plugs within minutes. Customers who had paid $7,000 for these cars were understandably furious. Gibbs mechanics scrambled to diagnose the problem. At first, they thought they had a batch of bad engines. It wasn't until they started comparing carburetor numbers that they discovered the mistake. Chevrolet had to emergency ship the correct carburetors to the dealership, and mechanics worked overtime swapping them out. The carburetor fiasco added to the ZL1's troubled launch. Word spread quickly in the racing community that the cars had problems, further dampening sales. Some customers who had placed orders canceled them after hearing about the issues. For Gibb Chevrolet, already struggling with the high inventory cost, it was another nail in the coffin. Today, collectors prize cars that still have their original correct carburetors. The part number 3955205 Holley is so valuable that reproduction units sell for thousands of dollars. Price shock returns and redistribution. The $7,000 price tags on ZL1 Camaros created a unique problem in automotive retail history. Cars being returned to the manufacturer, not because of defects, but because dealers simply couldn't sell them. Fred Gibb Chevrolet, stuck with dozens of unsold ZL1s, negotiated an unprecedented deal with Chevrolet to return some cars for redistribution. This had never happened before with a special performance model. Chevrolet found themselves in an awkward position. They had a dealer who had ordered 50 cars in good faith, based on Dick Harrell's assurance that racers would buy them all. Now they had to figure out what to do with returned inventory of the most expensive Camaros ever built. The solution was to quietly redistribute the cars to other high-performance dealers across the country. Dealers like Yenko Chevrolet, Nicky Chevrolet, and Baldwin Motion received allocations of ZL1s they hadn't ordered. Some were more successful at moving them, often by reaching out directly to known racers and collectors. Others faced the same problem Gibb had: customers who loved the performance but couldn't stomach the price. The redistribution created interesting provenance stories for collectors today. Some ZL1s show multiple dealer stamps as they were shipped from dealer to dealer trying to find buyers. Documentation from this period is scarce because dealers didn't want to advertise that they were selling used new cars. A few ZL1s sat on dealer lots for over a year before finally selling, often at discounted prices just to move them. The price shock phenomenon taught Chevrolet a valuable lesson about the upper limits of what performance enthusiasts would pay. True racing specifications. Looking at the ZL1 specifications reveals just how serious Chevrolet was about creating a race engine. The 12-to-1 compression ratio was at the absolute limit of what pump gas could support, and really demanded racing fuel for optimal performance. This wasn't a compromise. It was a statement that this engine belonged on a track, not the street. The solid lifter camshaft was pure racing hardware. With 0.560-inch intake lift and 0.600-inch exhaust lift, plus radical duration and overlap, it created the choppy idle that became the ZL1 signature. But those specs also meant the engine made virtually no power below 3,000 RPM. It was designed to run between 5,000 and 7,000 RPM, where it transformed into a monster. The valve train was built to survive sustained high RPM operation. Special heavy-duty valve springs, chrome moly push rods, and reinforced rocker arms could handle 8,000 RPM pulls all day long. The forged aluminum pistons were designed for racing loads, and the forged steel crankshaft was cross-drilled for superior oiling under extreme conditions. Even the 850 CFM Holley 4-barrel was racing-sized. On the street, it was almost impossible to use full throttle without breaking the tires loose. But on a prepped drag strip or road course, that massive carburetor ensured the engine never starved for air. Every component was overbuilt for racing duty, which explains why ZL1s were so difficult to live with on the street, but so dominant in competition. Corvette price doubled with options. The two ZL1 Corvettes weren't just expensive. They represented the absolute peak of Corvette pricing in 1969. With the base Corvette starting around $4,800, adding RPO ZL1 at $4,718 nearly doubled the price. But that was just the beginning. The mandatory options pushed the total into truly astronomical territory. The required M22 transmission added another $300. J56 special brakes tacked on $400 more. F41 suspension, K66 transistor ignition, and other mandatory equipment pushed the bottom line past $10,000. For perspective, that was more than twice the price of a base Corvette convertible with a big block. It was Cadillac Eldorado money. The few customers willing to pay this price got something unique, essentially a race car with a warranty. But they also got a car that was almost unusable as a daily driver. The heavy clutch, racing gearbox, and brutal suspension made every trip an adventure. The lack of power steering meant parking was a wrestling match. No radio meant listening to the engine, which wasn't necessarily a bad thing. Both ZL1 Corvette buyers were serious racers who understood what they were getting. They weren't buying transportation or even a weekend cruiser. They were buying the most extreme performance car Chevrolet could legally sell. Today, that $10,000 investment looks like the bargain of the century, with these cars valued in the millions. But in 1969, it took either tremendous wealth or tremendous faith to write that check. More engines than cars built. Here's a fact that confuses many enthusiasts. Chevrolet built more ZL1 engines than cars to put them in. While only 69 Camaros and 2 Corvettes received ZL1s from the factory, Tonawanda assembled additional engines for over-the-counter sales and warranty replacements. The total production is estimated at around 300 complete engines. The extra engines were built with Corvette-style suffix codes and were intended for racers who wanted to install them in older cars or build dedicated race cars. Chevrolet's parts department would sell you a complete ZL1 in a crate for about $4,000. Still expensive, but without the cost of a complete car wrapped around it. These crate engines became popular with professional racers who could afford them. Many ended up in earlier Corvettes, creating what are now known as Day 2 ZL1 cars. Others went into dedicated drag cars, road racing Corvettes, and even some boats. A few were hoarded by dealers who recognized their future collectability. The over-the-counter sales created authentication challenges for historians. Some engines were installed in cars and represented as factory installations. Others were used and abused in racing, then rebuilt multiple times. Today, finding an unmolested numbers-matching ZL1 engine is incredibly rare. The existence of more engines than cars also means that rebodied or fake ZL1 cars occasionally surface. Unscrupulous sellers have been known to install a correct engine in a regular car and claim it's an undocumented factory ZL1. Authentication requires extensive documentation and expertise to separate real factory cars from later conversions. Cosworth Clean Room Connection. The clean room at Tonawanda that built ZL1 engines had an unexpected second act in automotive history. After ZL1 production ended, the facility was repurposed to build another exotic aluminum engine, the Cosworth Vega twin-cam 4-cylinder. It's a strange connection between two completely different engines that shared only their aluminum construction and hand assembly requirements. The Cosworth Vega engine, developed in partnership with the British racing firm, required the same level of cleanliness and precision assembly as the ZL1. The clean room's air filtration, specialized tools, and trained technicians were perfect for building the high-rev and twin-cam engines. In a twist of irony, both engines were commercial failures despite their technical excellence. The parallel is striking. Both the ZL1 and Cosworth Vega engines were too expensive and too specialized for their intended markets. Both required premium fuel and frequent maintenance. Both were designed for racing but sold to street customers. And both are now highly collectible, with pristine examples worth far more than anyone imagined when new. The clean room itself became a symbol of GM's willingness to build exotic, low-volume engines for enthusiasts. It represented a time when car companies would lose money on special projects just to prove they could build the best. Today, that clean room is long gone, replaced by modern assembly lines. But its legacy lives on in two of the most interesting engines Chevrolet ever produced, the massive ZL1 and the jewel-like Cosworth, united by their shared birthplace. Race gas required like L88. The ZL1 shared many components with its iron block brother, the L88, including one critical requirement: a diet of 103-octane racing fuel. This wasn't a suggestion or a recommendation for maximum performance. It was a necessity to prevent catastrophic detonation that could destroy the engine in minutes. The 12-to-1 compression ratio was right at the edge of what any pump gas could support in 1969. Both engines carried warnings about fuel requirements, but many buyers ignored them at their peril. Stories circulated about ZL1s that lasted less than 1,000 miles because owners tried to run them on regular or even premium pump gas. The results were predictable: holed pistons, damaged bearings, and very expensive repair bills. The fuel requirement made ZL1s impractical for street use in many areas. Racing fuel wasn't available at your local Sinclair station. Owners either had to know where to buy it or mix aviation gas with pump premium to create something approaching the required octane. Some carried cans of octane booster everywhere they went. This created a divide between ZL1 owners. Serious racers had no problem with the fuel requirements. They were already running race gas. But street enthusiasts who bought the cars for bragging rights found themselves with very expensive garage decorations. Many ZL1s saw very little street use simply because feeding them properly was such a hassle. The octane requirement also affected performance. On proper fuel, a ZL1 was a beast. On pump gas with the timing backed off to prevent detonation, it was barely faster than a standard big block. This led to some disappointed owners who never experienced what their engines could really do because they never fed them properly. Steel sleeves in aluminum block design. The ZL1's aluminum block construction required clever engineering to survive the brutal conditions of racing. The solution was pressed-in steel cylinder sleeves that provided the durability of iron where it mattered most, while keeping the weight advantages of aluminum everywhere else. This wasn't a simple design choice. It was precision engineering that pushed manufacturing capabilities. The steel sleeves had to be manufactured to incredibly tight tolerances, then installed with an interference fit that would maintain proper cylinder dimensions under all temperature conditions. Too tight, and the aluminum block could crack. Too loose, and the sleeves could shift under load. The installation process required heating the aluminum block and cooling the steel sleeves, then pressing them in place before temperatures equalized. The sleeves were specially treated to resist corrosion from coolant and to maintain proper surface finish for ring seal. They were also designed to transfer heat efficiently to the aluminum block and cooling system. This was critical because aluminum conducts heat much better than iron, allowing the ZL1 to run cooler under racing conditions despite its high power output. This hybrid construction created unique characteristics. The engine warmed up differently than an all-iron big block, requiring special cold start procedures. The different expansion rates of aluminum and steel meant proper warm-up was critical before hard use. Racing teams learned to heat cycle their engines carefully to ensure the sleeves stayed properly seated. For rebuilders today, the steel sleeves create special challenges. They can be bored oversized like traditional iron cylinders, but only to a point. Go too far, and you compromise the sleeve integrity. Finding replacement sleeves for damaged blocks is nearly impossible, making sleeve repair a specialized skill that few machine shops possess. That's all for today, folks. If you enjoyed this video, don't forget to subscribe and hit that like button so you don't miss the next one. See you there.